Last lesson ended with a recommendation and a button. The data playground looked at what we had, two groups, a continuous measure, and pointed us at a two-sample t-test. We also had a number that looked damning. Billing tickets waited an average of 11.76 hours for a first response. Mobile app tickets waited 7.54. 4 hours and change between them. But an average on its own can't tell you whether that gap is real, or whether it's the kind of wobble you'd get by shuffling the same tickets into two piles. That's the question this lesson answers, and we're picking up exactly where we left off. Here's the wizard again, in the workbench sandbox. Same three answers as last time. We want to compare groups. We have two groups. And what we're measuring is continuous. Hours, not pass or fail. The wizard lands on the same recommendation, a two-sample t-test, and hands us a button straight into the tool. That button drops us on the hypothesis test hub. Every test we've run in this workbench lives here. It's empty, so we make one. New hypothesis test. And this is the editor. 3 things to set. The test itself, two-sample t already chosen for us. The alternative, two-sided, because we're asking whether there's a difference, not whether billing is specifically slower. If you had a directional claim, you'd pick greater or less, and the p-value would change. And alpha, the threshold for calling something real. 0.05, the convention. Then the data. Sample A is every billing ticket's first response time. Sample B is every mobile app tickets. 33 numbers and 46 numbers. The groups don't have to be the same size. And notice what stays unchecked. Assume equal variance. Left off, the tool runs Welch's T, which doesn't assume the two groups are equally spread out. That's the safer choice, and it's the right one here. There's the answer, and it appears the moment the second column lands. T equals 2.494. Degrees of freedom, 47.23, not a whole number, which is Welch's correction doing its work. And the p-value, 0.0162. In plain English, if billing and mobile really had the same first response time, you'd see a gap this big about 16 times in 1,000. That's rare enough to stop calling it luck. Reject the null hypothesis at alpha 0.05, and then the line most people skip, the 95% confidence interval. 0.816 to 7.621 hours. That interval is worth sitting with, because it tells you something the p-value never can. The true gap plausibly sits anywhere between about 50 minutes and 7.5 hours. It doesn't contain 0, which is the same verdict the p-value gave. But if your business case only pays off at the 7-hour end, you don't have enough data to spend money on it yet. The p-value tells you the difference is there. The interval tells you how much you actually know about its size. 2 things to lock in, because this is where p-values get misused. A small p-value says the gap is unlikely to be luck. It does not say the gap is large, or that it matters. And it doesn't tell you why. We now know billing genuinely responds slower, but not whether that's staffing, ticket complexity, or an escalation path that adds a day. The test narrows where to look. It doesn't do the looking. One honesty check before we move on. A t-test leans on the group averages behaving reasonably, and our data is right skewed. A handful of tickets sat for 30 or 40 hours and dragged the mean up. At these sample sizes, that's usually fine. But usually fine isn't proof, so let's not take the t-test's word for it. Same run, same 2 samples. We only change the test. Mann Whitney U compares ranks instead of means. It asks whether billing tickets tend to sit higher in the queue order, and it doesn't care that our data is skewed. U equals 498.5. Z, 2.585. P, 0.0097. The same verdict, reject the null, from a test that makes almost none of the assumptions the t-test makes. And read the note underneath, because this is the kind of detail that decides whether you can trust a number. Untied samples, up to 20 per group, get an exact p-value. Beyond that, the tool uses a tie-corrected normal approximation. Ours are 33 and 46 with repeated values. So it's the approximation. And the tool says so out loud, instead of leaving you to guess. Switch back, and the t-test result is exactly where we left it. Nothing was overwritten. The tool recomputes from the same 2 columns each time you change the question. Two different tests, two different sets of assumptions, one conclusion. Billing really is slower. When those agree, you can carry the finding into a room full of skeptics. So here's what we can now say and defend. Not billing looks slow. Billing's first response runs somewhere between about 50 minutes and 7.5 hours longer than Mobile, and two independent tests put the odds of that being chance at under 2%. That closes out Analyze. We started this chapter with a process we couldn't grade, and we're leaving it with a measured, tested, defensible cause. Next chapter is Improve. And the first question there isn't what should we fix, it's which fix earns its place. We'll score the candidates side by side. See you there.